Okay, in this video, we're going to look at some examples and review working with a domain of a function. Remember, for algebraic functions, at this point, we basically have two things that could violate domain. And that is, we're not allowed to divide by zero. We're not allowed to take even roots of negative numbers. Later on, when we add on logarithms, we'll have another restriction. If you go on to pre-calculus 2 and deal with our trig functions, of course, they'll have their own domain restrictions. But for now, with our algebraic functions, we basically have two places where we can break domain. And that is if we divide by zero, or if we have square roots of square roots, basically. Fourth roots also, but for the most part, we'll just deal with square roots. Okay, so our first example here is the function f of x equals 3x plus 1 over x squared minus 9. Since our problem involves division, that's one of the red flags that comes up. Okay, we have division. Is it possible that are there values of x that would cause us to divide by 0? And so we find that out by solving the denominator, x squared minus 9 equals 0. And we do that. So we can do it a couple different ways. Simplest ways, bring the 9 over and apply the square root. And we get, there are two values that cause the denominator to be 0. Positive 3 and negative 3. So therefore the domain is x equals positive 3. X can be anything but positive 3 and negative 3. And we can use the shorthand way of writing that. I know in a lot of the homework problems, they probably forced you to do interval notation, and that's good to practice the interval notation, but usually when we exclude a few values, it's pretty standard to just state what those values are. And so therefore, everything but negative 3 and positive 3 will work and produce an answer for this function. So that's why it's a domain. Let's consider a second example here. G of x equals the square root of 5x plus 2. Here, with this function here, g of x equals square root of 5x plus 2, we are looking, once again, for domain. So another red flag comes up. We have stuff inside of the square root. Now, we don't set this equal to 0 because it's not a denominator. What we have to do, because it's a radical, is we say, well, we can't have negative stuff. So we have to solve the inequality. The stuff inside the square root, or a fourth root, or a sixth root, or any even root has to be greater than or equal to 0. Has to be greater than or equal to 0. So we solve that. And we can solve that pretty easily by just bringing the 2 over to the other side and then dividing by 5, and we get x is greater than or equal to negative 2/5. Now, generally, with inequalities like this, you are going to want to write the answer in interval notation. So to do that, one way to state it is with the inequality. If you're not told you have to use interval notation, then certainly you can just write the inequality. If we are going to put that in interval notation, then we would come in here and say, hey, we have our number line, right? And we have to be above negative 2/5. And it's everything above and including that point. So this would be the interval then from negative 2/5 to infinity. Parenthesis on the infinity, and because we're including the 2/5, we'd have a bracket on that, and that's if we wanted to put it in interval notation. Again, if the directions don't say otherwise, you certainly could state this using just an inequality as well. Okay, I'm going to do one more example here. So let's look at h of x equals x cubed plus 5x squared plus 6x. So again, as we approach domain, we're looking for, are there things that break the domain rules? This polynomial here does not have division by variables, so there's no need to set anything equal to 0. Nor does it have any radicals like this problem. So there's no need to solve an inequality. And since it lacks the two things that could possibly violate domain right now, then we know this actually works for everything. And therefore we can just say, hey, domain is all real numbers. We don't have to write anything else down. We recognize that it doesn't have the things that could violate domain. And so therefore we have domain of all real numbers.